146 students joining us online. So, okay, for these sessions, I would like to invite Ibu Mat.
Hello, STP student. How are you guys? Can you hear my voice? I ask you all, could you please open your cam for a while and then open your microphone to say hello to all respected professor here. Are you ready, guys? Open your cam. Okay. Can you see me anyway? Just a moment. Okay. Okay, so everyone, today we have 4 respected professors here with us. Atta, can you hear Ibu Maria's voice, Atta?
Yes, Bu Maria, your voice is audible.
Okay, Nasi, could you hear my voice, Nasi? Hello, Naswa, can you hear my voice?
Yes, ma'am.
Okay. Okay, so today we have Professor Iwanta with us, Professor Ken Jujai, Professor Murase, and Professor Katramis with us. And we also have 34 students from Japan and also 23 students from ITS and IA 601. I know that now you are in anywhere because lecture will be online, But next week, remember, Wednesday we will have exhibition, and all of you need to talk with your colleague from Japan and exchange idea. Okay, everyone, can I ask you guys to use your reaction button and do a short video using your reaction button? You can use your trumpet, you can use your thumbs up, you can use anything that you want, please. Okay, thank you, Naya. Thank you. How about everyone? You say hi, please, to your friend on the screen. 1, 2, 3. Hi. Yeah, very nice having all of you guys. I hope you can meet them next week. Because this week we are still in a recess situation. I will explain to our Japanese friend after this. But for sure, we would like you to interact and learn. Okay? Today we are going to learn from Professor Katramis. And after that, we are going to learn from Professor Iwata. And I also will conclude by my short presentation about what's happening in Indonesia. Are you ready, guys? Let me call. Hang on. Let me call. Could you please go to the next screen? Yeah. Could you please, hang on. Let me call Kevin. Kevin, are you ready? Call Kevin Othniel.
Yes, I am ready.
Okay, you can ask question as well, yeah? You can ask question, not only like listening to the lecture, but you also can ask question. Hello, Timothy, are you ready?
Yes, Bu.
Okay. Farisal, are you ready, Farisal?
I am ready, Bu.
Okay. So everyone, let's start our conversation and learning, and it will be started from by Professor Katramis. Yes. Prof, the time is yours. So much.
Oh, bisa kasih.
Okay, good afternoon again. I hope you have a good lunch and welcome the over 150 students to the Zoom meeting. So this session is about energy transition. And there will be two interesting presentations by Professor Iwata and Professor Maria about transition, about energy transition in Japan and Indonesia. And I thought maybe I shouldn't talk about energy transition. Why don't I talk about something that is broader, which is sustainability, the transition. What do we mean by sustainability transition, where energy is one part of a bigger and broader problem. So, as you know, we are all facing very broad sustainability challenges, climate change, issues related to biodiversity. We hear a lot of news about disasters, climate disasters that are taking place around the world, including Japan, including Indonesia, United States. Migration, 100 million people are migrating every year because of climate change. So this is a very, very big number. So, and probably you heard about the Sustainable Development Goals, which basically a way to deal with these challenges. It's basically different kind of goals and targets that they're supposed to be tools, solutions to deal with these challenges. Sustainability challenges are often described in the literature as wicked problems. Wicked means bad problems. Why are they wicked? First, they are difficult to define clearly. There is a lot of interaction, interdependencies. Sometimes there is uncertainty. What's going to happen to this problem in 5 years or 10 years? Often not stable. Sometimes one solution is not enough, or the solutions are not always clear. Also, they are socially complex. it requires the consent of different stakeholders. And they are not the responsibility of one single organization. And of course, and this is very important, it involves changing behavior. So individual behavior is very, very important. So one example of a wicked problem is climate change. Climate change is complex, it's interdependent causes, it's multidimensional, it's socially constructed, and also the solution is technological, but also non-technological. There is a lot of solutions, and sometimes there is also unwanted result effects. And the scope, for example, is global, but it's multi-sector. So when we talk about energy, for example, it affects biodiversity. It affects sometimes water system. It affects food system. So this is what we mean here by the complexity. And the policies are policy goals and instruments, but also sometimes conflict and disagreement. So how do we define transition? Transition is a very important word in sustainability science. So transition are defined as, this is a bit difficult, like evolving or key evolving processes, different kind of processes in the society, in the economy, in the ecology and technology that are building together toward a systematic change of something. So think about renewable power, for example, renewable energy, how it's coming together from the technological perspective, political perspective, social perspective, economic perspective, are all evolving together to move to a decarbonized, a new system. This is what we call a transition. So sometimes it's a shift also, transition or systemic innovation between the social and technical systems that has new technologies like hydrogen or solar power or wind power. These are new technologies that could change the system. And they are always co-evolving together with other kind of technologies or other kind of like elements. There is multi-actor interaction. So we're not only talking about the government, we're talking about the private sector, we're talking about the university, we're talking about individuals, we're talking about nations sometimes, or local governments. So there's a lot of interactions. And sometimes the process is very long. So we don't talk about 2026 or 2027, we're talking about 2024, 2040, or 2050, or 2060. So transition can take a long, long time. And there is a lot of definition of transitions. And usually there is something called pre-formation or like startup of a new technology. So something that comes very, very small to the system, like solar power or like wind power 20 years ago, how they were very rare at the beginning, but now they are part of the policy. They are part of the energy mix. And then there is the acceleration. So now we are in the acceleration phase of building solar power, of building wind power. So, and then there's this stabilization. And this is where hopefully we will like have a stabilized kind of like transition system based on this renewable technology. So most countries are in the first two phases. The first one, the startup phase or the acceleration phase. But we haven't reached stabilization phase. No country achieved decarbonization. So most countries are in the first two of these phases. And it's very, very important to address or cope with sustainability challenges to actually move from the first phase to the second one, which is the acceleration. And that's why sometimes climate action is very, very important to accelerate, to deal with climate change, with high urbanization, biodiversity loss, and also food security. So governance is a very, very important word in sustainability transition. And governance is not only about public policies, but also about innovation and different kind of like policies. So governance here relate to many, many other keywords like transparency, accountability, collaboration, partnership, participation, different kind of stakeholder. And it actually refers to how these systems are very complex and require attention to different elements and different stakeholders. And it requires cooperative approach. So it requires collaboration, partnership, where both government and non-government actors work together in public and private network. And also governance is about how different actors come together to come up with something new, with something meaningful in terms of policy decisions, or how they can coordinate their action. So there will be people who are following the rule to move to a new system. I will skip this a little bit. So important keyword for good governance is inclusiveness, to make different kind of stakeholder participate in the decision-making process. Participation, transparency, to make your data, for example, public, to share different kind of information about certain kind of project. Accountability and collaboration. So there is different kind of, this is for your reference. Later, I shared this slide with you. I'm not gonna go over them because of the time. But there is a lot of like, again, different approach to the idea of sustainability governance, like multi-actor, how to reframe the problem, how to have a vision. So vision, like when Japan or Indonesia, they come up with net zero. This is a form of governance. When we say, I want to reach 2050 decarbonization, net zero. This means it's a governance approach. It's called visioning or experimenting. For example, what I talked about earlier this morning about hydrogen. This is one way of experimentation in energy policy. It's also important that when we talk about transition, it's not only about the technology itself, like moving from the horse wagon all the way to a Tesla car. It doesn't happen like that. We need infrastructure. So infrastructure is very, very important, but it's also very, very complicated. As I mentioned earlier in the morning, hydrogen is not going to work if we don't have more, for example, fuel stations. These are infrastructure. So there's a lot of other aspects, like the industry, the market, the fuel structure, the vehicle, the road, the financial rules, different kind of elements are all supposed to be the governance about this configuration. So this is a very good definition about socio-technical transition. It's fundamental. It means it can be disruptive, like new technology. Multidimensional, it means that it's not only the technology, but also the organization, the institution, the politics, and also it's long-term change. So we're talking about 20 years, 30 years. 50 years of socio-technical system. And again, they are a response to sustainability challenges, and there's also a way to change the world into a better place. One interesting thing about sustainability transition is that sometimes they are contested. So sometimes nuclear power versus renewable power. There is a lot of contestation. There's a lot of conflict. There is a key role for public policy. Sometimes there's winners and there's losers. Who's gonna win from shutting down, for example, a nuclear power plant, and who's gonna lose? So there's a lot of complexity regarding these issues. There's also different transition phases, like cleaner technologies, whole systems acceleration, system interaction, but also places or phases where it's very difficult to decarbonize industries such as steel and cement and aviation. So it's very important maybe this will be for your case study to think about, like to pay attention to diversity. Who are the stakeholders who are involved in the question you are trying to look at? And also the economy of scale, the new infrastructure, and the risk of making one technology dependent on one kind of, for example, fossil fuel or natural gas, for example. And it's very important to ask the question, how sustainable is the transition? It's not only we transition from fossil fuel to, for example, blue hydrogen or blue ammonia or gray ammonia. We have to ask, is it sustainable, the ammonia? Even so, it's a very interesting and new technology. I think it's very, very important to ask this question. Sometimes there is a new problem when we have a new clean technology. For example, e-waste or lithium extractions for e-vehicles. And this is maybe the most challenging aspect of sustainability, is that sometimes we only focus on one challenge, one problem, but we have to see how it's affecting other problems. So lock in here is very, very important. And there are below here, it's written 2 conditions to initiate the transition. The first one is disruption, and the second one is alternative. So this disruption is like corona shock. It was very disruptive, made people think about energy consumption. In Japan, maybe the Fukushima nuclear disaster was disruption. It made the Japanese government and the Japanese society think about different kind of energy transition like scenarios. So it's very important to promote low carbon innovations, but again, we have to really focus on the diversity, and we have to think about how sustainable these practices are. So to wrap up this like very short presentation, is that we are facing many kind of sustainability challenges, and this research on sustainability transition can provide a lot of tools and way to think about policy and what we need to actually do to move further to into, for example, a decarbonized society. And of course, we have to remember that sometimes there is a problem shifting. So when we try to solve a problem, sometimes it affects another problem, or it could bring another kind of like sustainability challenges. So I will stop here, and maybe we will move to Professor Iwata's presentation on energy.
Thank you, Prof. Katramis. All right. So, regarding the next sessions, Prof. Iwata will share the information about the energy transitions in Japan. So, maybe we will wait for the share screen to change into.
Okay, so thank you very much for our introduction. So Professor Katarami's mentioned that was very important point about the energy transition. So I would like to explain about the highlights as a review of the online lecture. So it's very short time presentation from now. So as a Japanese strategy for energy transition, okay, so here is our Japanese government target again. So Japanese government released their basic energy plan like this. And they mention about the carbon dioxide reduction target is around 46% by 2030. And by 2040, we have to reduce carbon dioxide emission by, sorry? It's okay.
Yeah.
So 73 it's okay. Percent. Okay, thank you. And about the details, thank you. About the details, the Japanese government sets each target in each sector. Like the industrial sector, they have to reduce 38% reduction compared to the emission in 2013, like this. And the amazing value can be, you can see about the, for example, residential sector, we have to reduce 66% of carbon dioxide emission by, 2030, like this. And as you know, we import fossil fuel around 83% from other countries, and we have no natural resources inside of Japan, but only 14% of primary energy was produced by renewable energy like this, and totally half of the primary energy is for the fuel production and raw material use, and the other half is for producing electricity and heat. So even if we change our electricity resources to the renewable energy, the half of primary energy for the fuel production is still remains. So we have to change all of this energy system. And the in these years, 2022, our end-use energy consumption is around 30% for the electricity and 70% for the fuel and heat production. And then Japanese government sets a target in 2040. They try to reduce the end-use energy with economic growth. So we don't give up the economic growth, but however, for promoting energy saving measurement, we try to reduce the end-use energy. And at the same time, they try to reduce the fuel and the heat consumption by electrification like this. So you can see the ratio of the electricity is slightly increasing. And then the mixture of the contents of the power production can be changed to the renewable energy main resource like this. So 40 to 50% of total electricity electricity production will be from the renewable energy like that. So we have to achieve this kind of strategy for energy transition. This is the outline. However, as I mentioned in the online lecture, okay, next one.
Next one.
Yeah, thank you. So there is a difficulty of the consensus building to install the renewable energy because this kind of safety risks is very high, and most of the project of renewable energy installment have no contribution to the local community in energy and economic aspects. So this is a difficulty of consensus building. And there is another challenging was the installment of renewable energy. So we have to balance the supply amount and demand amount on the real-time basis about in the electricity grid system. So solar power and wind power is maybe installed in Japanese society, but it's very difficult to control. So this is the second challenge about the renewable energy. So here is the priority, as I mentioned. So reducing end-use energy with economic growth for energy saving as a top priority. And second one is electrification on the demand side and carbon neutral electricity. And as a final solution for the decarbonized society, the transition to non-fossil fuel like the hydrogen or ammonia. And here, again, was the contents of energy saving methodology. I skip. And for energy saving, the technology of heat pump is very useful. And finally, the demand side management, such as controlling the devices on the demand side, like an air conditioner or hot heater producer, they can control based on the power generation amount of the renewable energy. So this kind of total energy management is very important. And of course, including the electric vehicle control is also can be controlled to the renewable energy installment. And here is the example in Utsunomiya City. So you can see the central one, local energy company, Utsunomiya Light Power is a company name, but it is established by the Utsunomiya City local government. So they established this kind of private company, and they utilize their local power generation plant by waste. And in addition, the excess electricity production from solar power in the demand side, they collect all the electricity, then they provide or they sell to the demand side, such as the EV charging system or buildings. So this kind of energy management system with sector coupling meaning is the transportation sector and the residential sector coupling system. So this kind of total energy management system is very important for promoting local energy production and consumption. So this kind of system can be contribute to local economy circulation. So thank you very much.
Thank you so much, Prof. Iwata, for your sessions. And then as we learn about the sustainability and also the energy transitions from Japanese side, then I would like to invite Ibu Maria to share about the energy transition on Indonesia side.
You. Hello. Hello. Okay, what we learned just now from Professor Katramis and also Professor Iwata is about energy transition in Japan. Okay, so now I give you guys 2 or 3 minutes. Please talk to your friend. Indonesian student, ask your Japanese student, with them all, hello, hello, okay? And then ask, did you observe those transition in your country? Did you see the transition in Tokyo? Did you see that now in Tokyo, high-rise building try to use sensor to reduce electricity use? Did you see all the story that's shared by Professor Katramis and also Professor Iwata? That's the first question. And then the second question, what are the challenges? What are the challenges for energy transition in Japan? 3 minutes starting now. Okay, guys, please talk to your friend. Let me ask you, did you observe, did you see the energy transition in Tokyo?
I don't think so because in Tokyo there are a lot of high building and the density of the building is very, the high density of the building, so it is no space to make a space of the electrons. So this is one challenge for balancing. So
Fine, have you shared the PowerPoint with all your with other participants?
Maybe not all of the PowerPoint, Bu Maria, but from today's
This session.
these sessions, yes, on the
Okay, could you please share that PowerPoint? And then student on Zoom, student who are now in Zoom, I will give you opportunity to ask question after this, yeah? You can ask question after this. You see the PowerPoint of Professor Katramis and also Professor Iwata. You can ask question after this. For you who are in this room, so now take the time to talk. My first question, did you see the program initiated by the government to decarbonize Tokyo, to decarbonize Japan? Did you see? And then what is the challenges? Maybe the challenges is young people like you are not really aware about the energy transition. Okay, guys, please ask question and discuss.
also I put the materials on the WhatsApp group so students can access.
Yes. The PowerPoint you can find in the WhatsApp group, so you can also look at the PowerPoint. Okay. Two questions. The first, did you see all of the energy transition? And the second one is, what are the challenges? Okay, while our colleague here in this room discuss, please keep going with the discussion. After this, I will ask you to answer and explain the question. I will give opportunity to the student in the Zoom. If you have question, everyone in the Zoom, if you have question, please raise your hand. Any question directly to Prof. Kadramis or Prof. Iwata? Anyone want to ask question? Shifa, do you have question, Shifa? Yasvi, do you have question? Anyone? Come on. If you have question, raise your hand. Paras, if there's a question, please let me know, yeah? What's the challenges? What's the challenges you see? Because Professor Iwata mentioned Japan has no natural resources to generate energy. You import energy. That means energy transition is very important for Japan, right? And Professor Katrami says transition is very, very challenging. It is not easy. Okay? Patel, have you discussed with your friend? Look. Why? Oh, okay. Wow, I can see this group is very enthusiastic discussing about the situation. Okay, everyone, Professor, I will ask from this group. Please, what are the answers? You can share the microphone with your colleague. Did you see the transition happening in Japan, or to be particular, did you see the change happen in Tokyo? And what are the challenges?
In Tokyo, I watched the increase the solar panel and electric vehicles and so on. I can Julia.
Is it in commercial building or in houses?
Houses and buildings.
Okay, commercial building and also houses. A lot of solar panel. Okay, that's the transition that you observe. What are the challenges? What are the challenges?
All right, my name is Seina Vane. I'm from Borobudur. So the challenges in energy transition is the different opinion, or we can say the difficulty in of consensus building, where there is pro and contra on energy transition. For example, in wind energy, there is a claim that some people might say it was risky for the wind.
The wire? Oh, windmill. You mean the wind energy? It is risky because it is so big and moving all the time. Okay.
And there's also some
Noisy.
and there's also some contra because it produces a loud noise and
Loud noises. In Japan, how much the use of wind? Do you have a lot of wind energy? You don't have wind, or you have a lot of wind energy? No, not at all. So the challenges you mentioned is that general challenges.
General challenges, for example, environment.
Yeah, but make it in Japan because today we are talking about energy transition in Japan and in Indonesia. They don't have wind energy. They have power solar cell. So please pick the challenge in Japan context. Okay, roll the ball first, and then later you can discuss with your friend what are the challenges in terms of. Yeah, sorry, no, give it to me. No worries, just throw it to me. Okay. Solar cell, what are the challenges if it is solar cell? But maybe this group have different opinion. Okay, what energy transition project in Japan or in Tokyo that you discuss with your friend? Yeah, okay. Can I have your name?
Tatsumi.
Tatsumi.
Yes.
Yes, please, Tatsumi. What are the energy transition project in Japan?
To install the hybrid car, like a e-waste MCB, to install to Japan. The challenges is highest cost is challenges.
Very high cost. Yeah, do you want to add something?
Other than the high cost, the challenges come from the society where many Japanese citizens or Tokyo citizens still prefer gasoline-based vehicle because it's more convenient and the gasoline is easier to be accessed.
Wow, very good point. Thank you for sharing. Can I have the poll? Okay, everyone. 2 points from these two groups, PV and then electric vehicle. But people in Japan still prefer to have gasoline. Why? Easy to access, right? Anyone want to share others? Anyone want to share what are the projects that you observe in Japan? Do you want to share this group? This group want to share? Which group want to share? I really want to hear. Ibu, throw me the ball. Throw me the rolling ball. Who want to share? Anyone? Hello? Anyone want to share? Let me learn from you. Come on. Okay. Okay. What are the project energy transition that happened in Tokyo?
Okay, we already discussed that Japan is started to popularize the methods for solar generation in every household to become more efficient energy. But the challenge is not many household has it because the cost
Very expensive.
may expensive.
Okay, let me ask your colleague. Do you have solar panel at your house?
Yes.
You have. Your parent bought the solar panel. Is it good or sometimes it is not consistent, the electricity?
Good.
Good. So you and your neighborhood, all of them, your neighbor, do they all have solar panel? Everyone in your dwelling area have solar panel or only several?
Not so all.
Not all. 50%? Less. 30%. So 30% in the one complex have solar panel. 70% have no solar panel. Is it because solar panel is expensive? The price is very high?
People Don't think. Use solar panel.
People don't think that use solar panel is important.
My pertama.
Yeah.
So solar panel company.
Oh, your parent is working in the solar panel company.
Us.
Yeah. Okay, but not everyone happy with the solar panel. Is it? Okay, yeah. So government try to encourage more use of solar panel, but not everyone understand and happy. Maybe because change always hard. Professor Katramis mentioned change always hard. Okay, everyone. Now, let's think about Indonesian condition. I ask you one question. If installing solar panel is expensive according to Japanese people, do you think it is also expensive here in Indonesia? Yes, definitely yes. So the transition to greener energy, renewable energy, decarbonization hit the very big wall. Why? Money. Money-wise, Indonesian people has less ability to implement the renewable energy. Got the point, guys? So, Indonesian people have less ability. Not everyone, but mostly Indonesian people have less ability to buy renewable energy. That's the first one. And then the second one. First is cost, okay? Second is understanding. Not everyone have the understanding. Why? Professor Iwata mentioned, Japan has limited natural resources. Indonesia has a lot of natural resources. If I, at my backyard, dig the soil and found coal, why should I bother and use renewable energy? Why? I have a lot of coal here. I have a lot of oil here. Why should I change? Because I have a lot of natural resources. Get the point, guys? Get the point? First, costly. Second, we have natural resources. Third, awareness. Not many people understand why I have to think about that. Why I have to move and use electric vehicle. Where I can find the charging station. I give you 1 minute. All ITS students explain the one that I just told you to your colleague in Japan. Please. Explain what I just tell you in a fun way. Please, teman-teman, tolong diterjemahkan supaya semuanya bisa paham. Yuk, silakan. Yes, ya.
Sulit menjelaskan ini. Tadi juga saya pas interaksi agak pakai bahasa tubuh. Iya. Bahasa tubuh. Enggak, saya pakai bahasa tubuh kayak jelasin bahasa tubuh.
Okay, got the point, guys? Hello, everyone. Hi, hi, hi. Oh, okay. Now I ask you guys, come on, each group, pat the shoulder of your friend. Come on, come on, come on. Wake up, wake up, wake up. Ayo, ayo, ayo. Come on, everyone, just do it because everyone needs more energy. Come on, come on, wake up. Do you understand what I just explained just now? So what are the obstacles of energy transition in Indonesia? The problem, the challenges. Yes? Yes, we have a lot of resources. Yes, right? And then knowledge and understanding. Okay, yeah. Okay. Okay, guys, we need more energy, yeah? Maybe we need 2 boxes of lunch, yeah, to get more energy. I only have couple minutes, but I will explain you quickly this PowerPoint, and Fai, you can share the PowerPoint with all the participants. Go very, very quick. Okay, energy transition. Look at this. Indonesia is very high in using fossil fuel because of the number of people in Indonesia is huge. In the next slide, we can see, okay, I know that the font is small and I don't want to go one by one, but Indonesia has target like the one that's shown by Professor Iwata. Target for industry, we have to cut the CO2 by certain percentage. For transportation, we have to cut the CO2 by certain percentage. We have all of those. Next slide, Mbak Fai. And going on, Mbak Fai, next slide. Okay, industrial sector, Indonesia try to make industry change. First of all, industry always think profit. I don't want to lose. I want to have bigger profit, right? And then government said, all company has to make life cycle assessment to know how much impact that you contribute to the society. By doing that, they have to submit to the government. If they do not submit the report, they cannot go for market share. So if they want to stay in the market share, pasar saham, public company, they have to do life cycle assessment and ESG, environment, social and government report. If you make a business, you want to go to a bank, ask for money, loan, okay? Hello, I want to ask for investment. And then bank will tell you, give me your ESG report. Huh? What is ESG? ESG is environment, social, and governance report. Huh? It is compulsory? Yes. If you want to borrow money, you have to submit ESG report. By doing so, all companies have to do environmental assessment. Going down, by transportation sector. What is the transition program that done by the government? First, don't use fossil fuel gasoline. Don't use diesel. You have to use biodiesel. Government stop selling diesel. Government promote the use of biodiesel. Previously, we have premium, the type of fuel that has high emission. Government stop using that and sell Pertalite and Pertamax. That's actually the way to shift the carbon, decarbonization. Second, promoting more use of electric vehicle by providing incentive. Later on in the project, you also need to ask people, for example, do you have motorcycle? Do you have scooter? Yes. Do you want to buy electric motorcycle? No, I don't want to buy electric motorcycle. It is expensive. Hang on, government provide subsidy. If you buy electric vehicle, you will get incentive. So government try to encourage more use of electric vehicle. Next, Pak Bakfai. Commercial and household, encouraging the implementation of green building. Everyone, look at this room. Look at this room. Okay, look at this room. Okay, Rian, could you please help me? Turn on the light at the back. Faras, could you please turn on the light here? Turn on. Turn on. Click, 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 everyone. See? Now, turn off, please. Everyone, if we use big window like this, we can rely on natural lighting. No need to have artificial lighting. No need to have lamp, light. We can use natural lighting. Okay? Now, Wahyu, could you please turn off all the air conditioner? Fadel, boleh bantu? Turn off all the air conditioner. Woohoo, we will be home. Okay, turn off. Off. Matikan semua. Sudah? Mati? We don't have air conditioner in this room. What do you think? Do you think it's gonna be comfortable learning without air conditioner? Let us try. We will keep the aircon off and how long you can stay without air conditioner. Okay? And Ibu, turn on. Wait. Sit down, Wahyu. We will keep the aircon off and then we will see. Look at this room, everyone. Look at this room. Is there any ventilation? Access to open air? No. That means this room is designed to rely on aircon. Monday, when you go to the school, look at the room and then think, if the aircon is off, how long students bear to study? That means if we build a house, we have to think how to open a bit of the window to have free air coming into the room. Otherwise, here we feel okay, I'm comfortable, but outside we release emission to the air, right? We release the heat outside. We feel cool here, but outside is very hot. Okay, so now keep the aircon off. Okay, just a moment, don't worry. But we try to feel it, because if we don't feel it, we never think about it, right? Just now I got WhatsApp. Friday electricity will off. If electricity off, there is no iPhone. There is no screen. There is no laptop. There is nothing, right? You can imagine how heavily we rely on electricity. Morning time, you wake up, turn on the light, using shower, electricity. Take water from the dispenser, cold water, electricity. Using toilet, electricity, because water pump work. Going down by lift, electricity. Make a toast, bread, you put your bread in the toast, electricity. You eat soto, electricity, because it is cooked by electricity stove. You can imagine how heavily we rely on electricity. So, government try to implement green building principle. We are going to talk about that on Friday, and including solar PV. But solar PV only one out of many solutions. Not only solar PV, but what we are doing now, turn off the light, turn off the aircon, is part of it. Okay, we are going to learn about green building on Friday. And then, stopping the installation of 450 voltage, yeah, because the capacity of small houses very small. So the electricity distributed to many houses with very small capacity and very low in payment. And it is costly by the government, yeah. Promoting the transition of postpaid to prepaid token electricity. Before, I'm using electricity, at the end of the month, I pay. But now we are using token. Install the electricity, use when it's dead, that means electricity off. By doing prepaid, we are more aware about the use of electricity in our building. I know my time is already off and Pak Heri is already here. Maaf Bapak. Thank you so much Bapak for your willingness to share with us about READY program. I have to stop up to here. There are still plenty of slides, but can you please go straight? But later I will discuss this during my session on Friday. Yeah. So now, guys, think how much I rely with electricity. This morning, you may say, no, I don't need electricity. How about that me? Everyone using mobile phone, right? And your mobile phone needs electricity, right? Without electricity, nobody can watch YouTube. Without electricity, you cannot watch TikTok, right? Without electricity, you cannot call your mom, your boyfriend, and your girlfriend. That means our life heavily rely on electricity. While we are using electricity for comfort, but we also release CO2 to the earth and make a lot of global warming, climate change, and so on and so forth. So from now on, energy transition start from my lifestyle. Okay? Can you please say to one another, energy transition start from my lifestyle. I need to change the way I use electricity. Thank you so much. Back to you, aircon off.
All right, thank you so much, Maria, and also Prof. Tarik and Prof. Iwata for the sessions about the energy transition. So, for the next sessions, we will hear about how ITS effort to see and also go towards the renewable energy. And right now, we already have with us our speaker from Ready IS. So maybe all of you is questioning what is ready. Is that ready? But now this is a different ready. So I will invite Professor Harry to give informations and explanations about ready and ITS.
Everyone, if you say hot already, raise your hand, no fuck you, okay? And fuck you turn on the aircon, but wait for a while. I just want to check how much we rely on electricity, yeah?
Okay, good afternoon, everyone. First of all, I would like to introduce myself. I'm Gary. Surya Mojo from Department of Electrical Engineering. Today, I would like to present about the AD. Before that, I see there are many Japanese students, right? Yeah, okay. Patricia also, something can correct, Yombi, Bengushimasta. Kumamoto Daigaku, Bengushimasta. Do you know Kumamoto University, Japanese student? Kumamoto Daigaku? Okay. Skoshidake wata Yombi, Skoshidake to speak in Japanese. But because of 2010, I already there. To study for my PhD under Yamashita laboratory. Okay. Next. Actually, the REGI project is under collaboration between IETS and also Nanyang Technology of Singapore and also Universitas Katolik Widya Mandala Surabaya. And next. Next. Wait. Okay. Because of actually today should be Pak Dedet will present because of Pak Dedet now is under another business in northern part and Sulawesi, I think for Indonesian project and Patriot. So I now presenting his presentation. First of all, before that, I'm the director of RIT, but now Pak Dedet, the position is the director of RIT project in IES. And nowadays, we know that the global warming under 2000 in the world are lower to 1.5 degrees Celsius, refer to pre-industrialization era, and this figure illustrate current technology during previous world, and basically before 1980, I think, in industrialization process in Napoleon Bonaparte, I think, mechanization, steam energy, union locomotive or some other technology related to how to generate the machine, still until 1890, and then move to around maybe around 19 or 19 early 19 electrification gradually increased, and start from around 1980 the computer automation growing rapidly, and now in 2020 I think all of you already know about how the technology in internet and also internet of things and cyber AI is growing rapidly about that. And next. And the background and motivation of the program in Indonesia is because of the Paris Agreement in 2011, 2016, I think, and Indonesian targeting of net zero emission in 2016. All of you maybe know that now the PLN as industrial electrical company in Indonesia showed a statement that until maybe in 2060, they will stop all the power plant of Indonesia, especially the power plant, the sources from the fossil fuel. Now, it's gradually they will substitute and replace the conventional power plant with the renewable energy. I already attend the meeting with the director of PLN in Bali around 2022, I think, in Bali, that the director of PLN makes statement that they will gradually to reduce of using fossil fuel as a power plant in Indonesia. So that is maybe later the class of renewable energy will be very famous, I think, in the world, and also especially in the United States and in Japan, I think. And Indonesian energy transition roadmap, and also renewable energy resources will growing rapidly 2025 until 2034. Next. And this is the roadmap to net zero emission until 2006. You know that the number of conventional power plant is increasing. Cleaner, newer, and renewable power generation technologies are increasing, and the type and complexity of system of and technology are increasing. I just remember while I was in Japan, 2010. At the time, I researched topic about renewable energy source, especially how to develop and how to make a new project related with renewable energy source. At the time, the price of solar PV is still high compared to current nowadays. And also, still, I mean, not many people of using such kind of renewable energy. For example, the simple one is solar PV, I think. Very rare at the time. But after I graduated from Japan, the using of solar power to use for supplying the energy in for example, in household is now increasingly. And also the price of the component, for example, the PV and inverter, for example, the price is now is decreased. And then the problem is still in storage. The price of storage devices. I think the battery is very low, I think. Sorry, because of the electricity problem.
Check.
Battery is full, I think. Hello. Okay. Okay. The electricity problem. Because now is when I put my body and my son.
Check. This one is more stable, I guess, Pak.
Yeah. Okay.
Check.
Yeah. Hello. Yeah. I'm sorry because the electricity. I don't know why. Whenever I move my body, the sun is disappearing. Next, but yeah. For the Japanese student and another, I think that is Indonesia, right? Solar PV potential in Indonesia. Right now, you can feel very hot, right? Yes, the same like in Japan in summer, right? Very hot. But I mean, this condition is not only in Java, not only in Surabaya, but all of Indonesia, the condition is the same. The temperature is, I think, it's the same from Papua. It's very high. The heat, irradiance. The radiant is energy potential to usually in watt per meter square. The maximum is around 1000 watt per meter square. So whenever you have the size of your table in this, for example, like this, I assume that the size is 1 meter square. So if you want to put the PV panel outside, the maximum power that can deliver by this size is about 1000 watt per meter watt, right? However, because of the technology, of PV right now, the efficiency maybe around now 30, around 30, I think. Whenever I stay in Japan and 2010, the efficiency of PV is still 10%. And now, because of the technology increase, the efficiency of PV or solar panel to convert the irradiance to the electricity is about more than 25%. So 1 meter square of the size of the dimension PV can deliver about 250 watt of electricity, right? So from this map, you can imagine that Indonesia is very potential for renewable energy, right? The same like in my home. In my home, I install solar home system, a rooftop system with grid tied inverter. That at this time, I'm not using the electricity from the PLN. I'm using the electricity from the sun, right? That's free. So I don't care about using air conditioner. In the same condition like this, very hot, because of fully supplied by the photovoltaic, right? Okay. Okay, next. But next. I'm too scared to my body because of. Okay. How about how how about the wind speed? Wind power in Indonesia. You can see Indonesia is not potential for wind power. It is different with in Japan or in Europe. Here, the wind speed is very low, except in the southern part of Java. Southern part of Java, maybe you know the bridge along the Java island, and also eastern part of Indonesia. The potential of wind speed is, a little bit high. So it is more potential compared to Java. Can you imagine whenever in ITS you install wind turbine in ITS, the same condition like that. You can see outside the wind condition is like that. I think around 3 meters per second. That is very small. Just to start the turbine, right? Very small. So there is not potential for wind power in Indonesia. In its part is okay, but mostly Indonesia is not have potential for wind power. Okay, next. And you can see in this table, the sources in Indonesia, PV solar, the potential is 3,000, around 2,000 gigawatt, and utilized is around still 0.27. The hydro is around 90, and the utilization of hydropower is 6.6 gigawatt. Bioenergy, wind, geothermal. So from these sources, the renewable energy potential in Indonesia is still not explored yet. Still very small of using renewable energy sources in Indonesia. Next. And now, what is READY, right? READY. READY is actually the project of READY is under Inspirasi project. Indonesian and EU Singapore Institute of Research for Sustainability and Innovation. So we can simple name is Inspirasi, right? Inspiration, yeah, inspiration. And in Inspirasi we have two main projects. The first is research pillar, And the second one is ready living laboratories. Ready is a renewable energy Indonesia integrator demonstrator of Indonesia. Demonstrator, so you can recognize demonstrator, living lab demonstrator. So if you go to ready plant, actually ready is living lab consists of many renewable energy sources. So you can demonstrate, you can make some research, the phenomena whenever the renewable energy is used for supplying the load. That is ready. So ready not is I'm ready. So just easy to remember, right? Ready. Right? The capacity is very high. Yeah, so renewable energy integration demonstrator of Indonesia. Right? Whenever I book it, yeah, besar. Okay, renewable energy integration demonstrator of Indonesia. So you make the sort of name is ready. Okay, next one. Okay, this is the schematic of ready. I think the student at the behind cannot clearly see this schema. Yeah, ready consists of actually photovoltaic power, photovoltaic power with is 500 kilowatt peak, yeah, right? And then we have biomass. The capacity is 50 kilowatt. Bismillahirrahmanirrahim, ya. The capacity is 50 kilowatt. And also we have hydrogen power. The capacity is about 10 kilowatt. But for the first stage, we already finished to build the capacity of solar power is about 300 kilowatt peak, and also 200 kilowatt hour and storage. That is the first stage. And how about 300 kilowatt peak of solar power? Actually, in the first stage, you can see we have many photovoltaic system. We have ground mount, the capacity is 50 kilowatt. The ground mounted PV usually at the land you can install the PV that is mostly used in daily life, right? Ground mount, the capacity of 50 kilowatt, and agrivoltaic PV with capacity is 200 kilowatt peak. What is the definition of agrivoltaic? Yeah, agriculture is you know very well agriculture. So you can make planting system under the PV. Usually, if you install the PV, ground mounted, for example, so the land under the PV you cannot use at all, I think. But if you are using the ground mounted, sorry, so agrivoltaic PV, the land under your PV you can use for planting, right? To plant many things, right? So it can be useful for us. And rooftop PV, the capacity is 25 kilowatt peak, and floating PV, you know floating PV. The PV usually at the land, but in floating PV you can use down, you can use sea. So the PV installed at the top of something can be float, right? And 100 kilowatt simulated load. So we have a dummy load over there. And the battery, the capacity is 200 kilowatt hours. We have two battery storage. But the first stage we just install 200 kilowatt hour battery system using Xiaomi, Huawei macam Xiaomi handphone, right? Huawei Huawei Luna lithium-ion battery storage. And also we have EV charging station with the total is 200 kilowatt. So if you are using electric vehicle, you can charge in ready side. And we have very big EV charger at the location. And the transformer, we have the transformer. The capacity is 400, I think. I'm not sure. Yeah. And the function of transformer is to connect the ready site, ready plant to ITS electricity network. During this condition, the same time like this, the energy from ready is delivered to ITS network. The energy. So it can reduce the bill of ITS. Okay, so it is the same like in my home. Otherwise, whenever the electricity network from parent is outage, ready can supply itself. Ready can supply the electricity itself for all equipment in ready. Okay, next one. Okay, this is layout of ready. This is you can no pointer. So for biomass plant with the capacity of 50 kilowatt, I think in next stage, but now there is no biomass plant. And hydrogen plant, the capacity 10 kilowatt in the third stage of ready project. In the right side, on the right side over there, all those systems already available in ready. Whenever you want to go there, the right side of ready, you can see. And at the corner, you can see we have a EV charging station with total capacity is 200 kilowatt already available. If you want to charge your car, is over there. You can see here the EV charging station. Next one. And this is ready roadmap. Construction is at in 2024, and 2025 is now is running for the first stage. Only 300 kilowatt peak photovoltaic and 200 kilowatt hour energy storage by lithium ion. And the 2026 until 2029 ready project should be or can be used for research, can use for certification of electricity of the nation, and also collaboration with industries, how to, for example, solve the renewable energy problem in Indonesia, and also collaboration with another university in Indonesia and also outside of Indonesia. So, but because until now it's still in with Singapore, right? Next. And this is documentation of construction already. The location is maybe the student from ITS can understand clearly the position of ITS. You know Manarul Ilmi, right? The mosque. The western side of mosque, you can see the ready. I think there is very good place for you. During at night, you can make a cafe from there. So because of ready is very wide, 1.5 hectare of the size. Next, this is the construction of ready. Next, and that is the condition like now, right now. We have ground mounted PV, agrivoltaic PV, battery with capacity 200 kilowatt hour, load bank, switchgear, rooftop PV, and also EV charging. Can you imagine? Right now it's very hot, right? Very hot. That is also hot because of this condition is work from home, right? If you want to go to rate right now, you have to use hat or a white hat or umbrella because it's very hot. No trees, yeah, no high trees because of the location must free from obstacle, right? Must be from high trees. Why? Maybe you know why no high building near in radio because of PV. The PV must get the clear irradiance. Whenever you plant the high trees or we have a high building over there, the shadow will occur over there, so the electricity will reduce at PV, right? So this location is very free. Next. And this is the layout for the green colors. The next project for biomass plant, hydrogen plant, office building, and the behind of a ready ground mounted ready plant, you have floating PV, but now it's still just a land, right? Not floating PV. Maybe later we would like to float the floating PV. Next. And ready is the same like rate in Singapore. In Singapore, we have rate. They have rate, and in ITS we have ready. The same R, right? Rate and ready. The same in Singapore. The location of rate is very isolated. In isolated island. I'm sorry the name of the island. Pulau apa? Lupa saya ya. I forgot the name. But very isolated. You have to use boat to go there. But in ready of ITS, no boat. Just walk is okay, but not from here, but from mosque. Yeah, after you pray at mosque, and then you can go to my ready. It's very close to mosque. The same, right? And then this is the infrastructure of ready. We have MV, medium voltage, and low voltage distribution system. We have distributed generation storage system and LV panel. And also, of course, we have the electricity sources from PV power. Next. And we have EV charging station. All the, how can I say, behavior of the electricity ready are monitored by SCADA, right? So whenever you want to turn off, you want to monitor all the parameter of in ready, it can be monitored in CCR, right? The illustration is like that. Next. And overall system configuration of ready, first off grid, independent supply, backstart, transition, during on grid, peak saving, load leveling, smoothing, frequency voltage regulation. That is ready, so it can be separately operated by connected to ITS grid or isolated between two part already because of we have a global passport on that. Next. And that is the illustration, not illustration, but is the actual condition in ready. You know, the graphic over there is the electricity generated by photovoltaic, right? Very rough during at morning, right? Because of the installation or irradiation of the sun is very low, then the electricity generated by the PV power is very low also. Where during starting from 10 p.m. until 1 p.m., that is the maximum energy generated by the PV. But the condition of irradiation also influenced by maybe cold or weather condition. You can say the power is very rough, right? Sometimes up, sometimes down. That is very rough because of this condition. Can you imagine? My question is, can you imagine whenever the electricity power sources is like that? Whenever only photovoltaic only to supply the load, to supply your home. Whenever that condition is occur, for example, the irradiation suddenly is disappear, right? So no electricity. So that is the challenge of using electricity by renewable energy source. The fluctuation nature of PV will give the impact of stability in the system. So it's quite challenging, right? So the penetration of renewable energy sources in Indonesia or also in the world must be, limited. Not can handle by renewable energy source because of the fluctuation nature of renewable energy sources, right? It is different compared of using conventional power plant because of you can stable to supply the load. It's okay, but renewable energy is very rapidly fluctuate by the solar condition. Okay, next. And this is the same. This condition of radiance and the power of PV. During this case, on-grid operation with automatic manual based control. So, in order to shift the load, the shifting energy, right? You have to use battery. Okay. Electricity from the solar power only can be used at the daytime. Whenever nighttime, no sun, or you make your own sun. Yeah, no sun, no electricity. So that is very important to use energy storage, right? Battery. So you can shift the energy from the daytime to nighttime. However, the challenge of using storage, the price of the storage is still expensive compared to PV. I think all of you, for Indonesian student, every day you are using car, you are using motorcycle, right? How many times you replace your battery for your car or your motorcycle? Of course, the answer is I don't know, sir, because my parent always replace the battery for my car. Can you imagine what saya tidak paham Pak yang ganti baterainya papa saya gitu ya. The lifetime of the battery is very short, right? So you have to replace. So that is the drawback of renewable energy. The storage is still expensive, and also you have to replace in some time of period, some period of time, yeah. Because there is a drawback. Okay, next. And okay, next is too technical. Too deep. Okay, this illustration next. Okay, next one, yeah. Okay. What is the benefit of ready plant in ITS? I said before that during daytime, the electricity generated from PV can, reduce the electricity bill of ITS. You can imagine, with the assumption and electricity production of PV 307 kilowatt peak, the production of in a year is like that, and the electricity tariff for public facilities is around 1,000 blah blah, yeah. So in a month, the electricity electricity from the PV is about 5,000 million, ya, 50 juta ya, 50 juta rupiah dapat ini apa menggantikan mengurangi tagihan. Next, this next portion production. Okay, next. I already explained before. I think that the function of RAID program in ITS for testing, education, training, campus social responsibility, research and innovation. Okay, next. And that is the team for RAID. We have Pak Ari Baktiar. Pak Ari Baktiar is project manager. And then Pak Dedet actually today he will present, yeah, because of he has already business. Before that, I'm the same position with Pak Dedet, yeah. And under Pak Dedet and Pak Ali Baktiar, we have several teams, specialty for research. For example, we have Eco Campus Lab, Photovoltaic Lab, Hydrogen Lab, Agriculture Lab, and Biomass Lab. We have lab in the lab, right? The ready is living lab, then at the ready, we have also lab and lab. Next. And okay, next, I think there's the biography of the team. Next, Pak Vito and Kumaya. Kumaya is specialty in agrivoltaic. And next, and Pak Yusuf will responsible about hydrogen research. And then next, and next, sorry. Construction seconds too, because I think this slide, okay, I already explained before. In the next slide for the construction of biomass and the fuel cell. Next. 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 Okay, the agrivoltaic. You can see agrivoltaic. Agrivoltaic PV like a house, right? Seems like a house, but the PV can use for many things, right? For agrivoltaic, agriculture sector, for example. Next. Next. Okay. Too many summary. I will make some very summary, right? Ready is the living lab for research, demonstration, and collaboration. I hope you can go to my ready plan to know what is ready and how to fill the electricity generated by the solar power for daily life in ITS. Thank you very much for your attention.
Thank you so much, Prof. Heri, for the presentations. Maybe before we close, Bapak, if there is any questions from participants, if you have any questions about ready or about the explanation from Prof. Heri, please you can raise your hands and ask directly to Professor Heri. Is there any question?
Merdeka, Mas Kak.
Maybe in Japanese it's also okay.
Okay.
Yes, you can ask in Japanese. Prof. Heri also can answer in Japanese, yeah, Prof. Yeah. Or maybe from Professor, if you have also curiosity about the ready, you may, yes.
Imawa, Nemo is Kara. I think this very sleepy, I think. Nemo, yeah. Nemo. Toto Nemo, yeah.
Okay, thank you very much for your presentation. I have one question about the facilities inside of this university.
Yeah.
So amount of solar power was installed, but is there any additional facility, for example, how can I say it? In case of the emergency, people will gather, for example, from the disaster, or people gather inside of this university, then this kind of solar power will produce energy and keep, how can I say, keep people, keep people safe.
Yes.
Is that kind of facility?
Thank you very much for the first question. Actually, I just already make some emergency location of in case if any disaster, right? How about the solar PV during the disaster, right? Actually, the protection of electricity in ITS is very good. Whenever disaster happen, then the electricity will outage, right? However, will not cover directly the people in the disaster. You can understand what I mean? Yeah. For the location is available, emergency location for the people under disaster. But at the case of disaster, how about the PV? The PV will stop to deliver the electricity to this building because of you can now you can see mostly the solar PV in ITS is grid tied inverter. So the solar power is connected to ITS grid. Directly deliver the energy to the grid. Whenever the ITS outage, then the PV will stop to produce the electricity to supply the load in ITS.
Okay, thank you so much for the explanations. Is there any other question from participant? Maybe from online students, you may also ask questions to Prof. Heri here if you have any questions. Maybe any other questions from ITS or Japanese students? You can also ask in Japanese to Prof. Heri. You want to ask something to Prof. Heri? It's okay, in Japanese is fine.
大丈夫かな少し。
そう、日本語で。
日本語わーお Maybe Sensei will translate. 日本大丈夫。先生 will translate.
じゃあ、レイティそのレイティの施設を建てる敷地をどのように決めたかみたいな。英語でもいいと思います。
The question is very difficult because okay.
So, do you have any reason to decide the area to build the ready facility?
Reason, right?
Yes.
Yeah. Thank you. Nice question. Actually, it is very difficult to find the location of in Surabaya, right? Because of 1.5 hectare. The size of ready plant is very wide. The price of the land is of course very expensive, right? In Surabaya, it is difficult to find. So at the time, actually in current location, the location is how can I say green land location. for ITS, for not for housing. So that is how can I say in English? The location is not for yeah, green space, yeah, green space. But at the time, my rector, Professor Lazari, decided to use the land for ready. That add mass to build the ready over there. Because of ready is the green laboratory produce the green electricity. So that is the reason. Yeah. The question the question is very interesting. The I mean the, let's see the discussion many long time discussion to find the location. Yeah, thank you.
Okay, is there any other question to Prof. Heri? No questions? Okay, if there is no question, can we give a big applause to Prof. Heri for the time and to appreciate Prof. Heri's sessions today. I would like to invite Prof. Iwata to give souvenirs to Professor Heri. And this is the souvenirs and certificate. Maybe we can take picture here in the middle. Yes, thank you. All right, thank you so much, Prof. Heri, and also for students. Thank you for actively involved in the discussions.
That's it. Thank you very much for.
All right, so thank you so much, Prof. Heri, for the sessions. In the next 10 minutes, maybe we still have time to learn more from student experience before we learn about another important trip. So I would like to maybe invite Ruben to share the internship experience, like maybe 7 minutes, Ruben. So Ruben also got the opportunity to have like an energy transition project. So he will share with us one of the project that happened in Indonesia as well. So Ruben, time is yours.
Okay, so sorry. Okay. Okay, so first of all, thank you for the professors and also all the colleagues here. So let me introduce myself. My name is Michael Ruben Julian Parede. So currently I'm the final year student of industrial engineering. So I want to present a bit about my last internship in PricewaterhouseCoopers. So the division is energy transition. So could we go next? Okay. So speaking about energy transition, what is the purpose of this PwC energy transition? So we have 5 scopes under the advisory line of service. So there is strategic supports for the net zero and strategy, and also policy, financial, and technical advisory, and also market and regulatory development of roadmaps. And the last is the multi-stakeholders engagement to align government. So next. Okay, so this is one of my slide of presentation that I prepared for PwC. So this is JETP Indonesia. It's like the government of Indonesia collaboration with GOI from the other IPG members, such as Japan, US, Canada, and also the G-Fans, the Glasgow Financial Alliance for Net Zero, where the joint targets is also to have the power generation by 2030 with 34% renewable energy. So next. Okay, so the total pledge of this JETP is quite large from all of the IPG, including EU, Japan, US, and then the G-Fans, with the total of 11.6 billion USD, and also with loan for USD 10 billion. With the pledge, we'll be focusing in 6 financing investment area, which is in the energy efficiency and the transmission and distribution, dispatchable of renewable energy, VRE, CFPP coal phase down, and also the development of the RE supply chain. Okay, first of all, I want to ask to Professor or any other colleagues, have you guys ever heard about the palm hydro energy storage? Professor? Sure. So I'll share a bit about the target of Indonesia hydropower. So based on the national state-owned 10-year project, by 2034, we're targeting to install 69.5 gigawatt of electricity, including 42.6 renewable, and then 16 gigawatt of hydropower, and also 10.3 of storage and 16.6 fossil. So where are we at today? Right now, it's currently in 3.5 gigawatt installed by the state-owned company of PLN. Okay, so I'll introduce one of our pipeline projects in Indonesia. It calls the Upper Cisokan West Java with capacity of 1.04 gigawatt, which the commercial operation date is 2026. So actually this project is already planned long time by 1990, but due the social economics and then the land acquisition problems, so this project is facing many of problems here. Now, after the new financing and new construction model, so they will be integrated by 2026 or 2027 in the commercial operation date. Okay, so I'd like to show like how does the PHES or the pump storage